All right, guys, so we're back. So the last question we did was 24, which we get positive p squared. So I'm asking now, who would like to do question 25 for us? Ms. Genovia, would you like to do question 25 for us?
Answer 6A.
Go ahead, Ms. Genovia. What's the answer?
So the answer is 6A squared.
All right, 6A squared. All right, who would like to do question 26? Miss Waysom, you want to do question 26 for us?
Sure, sir. 5x squared.
All right, so notice that this x is the uppercase x, so we have to write it in the same fashion. So this 5x uppercase x squared. All right, would like to do question 27. Ms. Shea, can you do question 7 for us? 27 for us?
Sir, negative 15Q.
Negative 15, continue.
Q.
Say that again, Ms. Shea.
Negative 15Q.
Is it just 15Q, negative 15Q? Notice that we have a Q.
Negative 15Q square.
Correct. All right, so negative 15Q squared. All right, who is going for question 28? Ms. Green, you want to do this one for us?
Yes, sir.
Go ahead.
Positive 9Q square. 9PQ square.
9PQ squared. All right, what about 29? Who is doing 29? All right, I'm going to, Ms. Lang is just coming in. I'm going to ask Ms. Lang to do question 29 as soon as she is able to hear me. Ms. Lang, are you there? Are you hearing me, Ms. Lang?
Yes, sir.
All right, I want you to do question 29 for us. Have any answer for us?
Sir, not yet.
Okay. You're working on it? You're working on the answer, Ms. Lang, or should we go to someone else?
Sir, you can move on.
All right. All right, Miss Waysom, can you do question for us, question 29?
Yes, sir. Negative 24 m cubed n raised to the 4th power.
All right, negative 24
Yes, sir. M cube.
m cubed
N raised to the fourth power.
n to the fourth power.
Yes, sir.
All right. Thanks, Miss Witham.
Yes, sir.
All right. Who would like to do question 30 for us now?
Me, sir.
Who is that, Miss Williams?
Yes, sir.
Go ahead, Miss Williams.
Negative 21 a cube b to the first power
1 a cube
b
b to the.
first
All right.
power.
So you can just write negative 21 a cube b. All right. Let me see the hands of those who are comfortable with what we are doing so far.
Can you repeat what you said, please?
I said, let me see the hands of those who are comfortable with what we're doing so far.
Oh, okay.
All right, so I'm going to clear what we have here. And moving on. So here we have 4 more questions to the list. Who would like to go for question 31? Should I give you about 3 minutes to try them and then, all right, I'll give you 3 minutes to work on them. And then now, if you're ready, just raise your hand. Anybody is ready for us? 31, who wants to go for 31?
I will, sir.
Ms. Williams?
Yes, sir.
All right, go ahead.
Negative 10 q to the fourth r to the sixth power
10q to the fourth. R to the sixth power.
Yes, sir.
All right. Anybody else got that answer? Let me see your hand if you got that answer. All right. Very good, guys. All right. So who is going for question 32?
Sir, I got positive 30 MNP.
All right. So 326530. And it will be positive. Why would it be positive, Mr. Shamar?
Because negative time positive give you negative and then one next negative and negative time negative give positive. Or I can just say 2 negative.
Okay. All right, so once you look at what you're multiplying, you count the number of negative. If you have an even amount of them, your answer shall be positive. Likewise, if you have an odd amount, your answer will be negative. Same thing applies when you're dividing. Just count all the negatives in it, and that also will indicate whether or not you have a positive or negative. So if you have an even amount, your answer will be positive. An odd amount, your answer will be negative. Who wants to go for question 33 now? Let me see if I can
Let me
body to do this. Miss Lang, try this one for us. Are you there, Miss Lang? Are you hearing me? I know sometimes persons just leave the scene, leave their device on, and go on to do something else. If you leave, then you're going to miss out on what we're doing. Miss Fabia, try question 33 for us.
Yes, sir.
Go ahead.
Question 33.
33.
I have 5 trees, 15 times 5, 45. I have 45 a cube b square.
Positive or negative?
Hold on. Positive, sir. No, sir, negative. Sorry.
Okay.
Sorry.
Yeah, because we only have one negative here.
Yes, sir.
One is an odd number, so our answer going to be negative. So it is negative 45.
Sir, it should be 75.
75.
Oh, sorry. Yeah.
Oh, true.
Yeah, that's
Yeah, that's true.
25 times 3, yes. Correct.
75.
Based on for the correct number. So it is negative 75
A cube b square.
a cube
B square.
b squared. All right. All right, thanks much. All right, while you're at it, Miss Waysom, do question 34 for us.
Sir, you hearing me?
Hearing you now.
Yes, sir. Negative 5 m raised to the 5 power.
Negative 5.
Yes, sir. And m raised to the 5 power.
All right, so m to the 5th.
And then n raised to the power of 4.
N to the 5th. That's it?
Yes, sir.
All right, thanks very much, Miss Waysom. All right, so we should by now, by way of practicing, understand the rules and the concept of how to answer these questions, all right? And so this would now bring us to the end of simplifying algebraic terms. So we want to move on to another topic. So I'm going to stop sharing this. And then now we're going to share another topic. So our next topic that we'll be looking at, brackets. All right, now we would have met brackets at some point before, especially when we were looking at what we call bedmass, which tell you the order in which we carry out arithmetical operations. And generally we work out what is in the brackets first. But the brackets that we're looking at now is brackets as it relates to the distributive law. And we are still on the topic of algebra. So we're going to be applying distributive law based on brackets. Now, before we jump into the concepts, anybody can give us an idea or explain to us what or even state what the distributive law states. Ms. Waysome, go ahead for us. Are you hearing me, Ms. Waysome?
Sir, go again, please.
Can you state the distributive law for us?
Sir, I really don't know how to explain it, but I know how it works. It's basically just what is outside of the bracket is being multiplied with whatever is inside the bracket.
All right.
So for example, you have 5 and then x plus y. Inside the bracket, you have 5 times x and 5 times y.
Okay, so in other words, you can demonstrate, but you don't know what the law is stating. All right, so it is good to know the laws, because while you understand the laws, it makes the concept clearer in your mind. But pretty much that's what we're doing, Ms. Waysome. We are going to take what is outside the bracket, multiply what is inside in a distributive way. The word distribute means to give out. And so when we're multiplying distributively, we're taking what is being multiplied and we're multiplying it to each term in the bracket in a distributive way, meaning we are giving what is outside to what is inside distributively. All right, so the distributive law really states that for a set of quantities or a set of numbers, multiplication is distributive over addition of a set of numbers. So it really means the same thing, what you have on the outside, because when we say multiplication is distributive over a set of numbers, the set there going to be a group and the group going to be in brackets, all right? So the multiplication would be what is outside, we are multiplying. So we multiply what is inside the brackets, and what is inside the brackets, those are usually added. So that's why we say multiplication is distributive over addition and subtraction for a group of terms. All right. So the general rule here when we're dealing with brackets, so brackets are used for convenience in grouping terms together. Now, before we look at the rules, one of the important things with brackets is that when we use brackets, the bracket is encapsulating a group of terms, and that group of terms, all encapsulated in the bracket, is treated as a single unit. So whatever is in bracket enclosing the bracket, it is treated as a single unit, but the bracket is what gives it its singularity. All right, so let us look at the rules when we're dealing with brackets now. So when removing brackets, each term within the bracket is multiplied by the quantity outside the bracket. So this in essence is the distributive law. Rule 2, when you have a minus sign, in other words, when we have a negative sign in front brackets, the sign of all the terms inside the brackets are changed when the bracket is removed. And that law is still obeying the distributive law, but the fact that we have a negative in front the bracket, so let's say we have -2, and let's say we have x plus 3 minus, all right, let me say 3y minus z. All right, this is supposed to be a z. Now, when we have negative in front the brackets, when we multiply out, the signs of the term in the brackets will change to their opposite. So if you notice here, the x would be a positive inside the bracket. The 3y would also be positive inside the bracket. Z would be negative inside the bracket. But using the negative outside to multiply what is inside, we are really following the rules when we're multiplying positive and negative numbers. So this is actually the multiplication rule for integers. All right, so -2 times positive x will give you -2x. And -2 times positive 3y will give you -6y. -2 times -z, so negative times negative give you positive, so -2 times -z give you positive 2z, right? And so this is where the second rule comes from, to say that once you have a negative outside the brackets, when the brackets are removed, the signs that you would have in the bracket would change to their opposite. So the x now becomes negative, the y become negative, and the z become positive. Let me see the hands if you all understand what I'm saying here.
Sir,
Yes, go ahead.
so where you have 2 times z.
We have 2 times z.
Yes. Where you have the,
All right,
I'm not seeing the screen.
let me see if I can, all right, here we go now. So what you're saying now, miss?
Where you have the 2 times the
It's
z.
supposed to be 2z. I mistakenly
Okay.
stopped the 2. All
All
right,
right.
it's supposed to be 2z. All right. So that should clarify that. And everybody understands what this rule is saying here. So if you have a negative in front of the brackets, the signs inside the bracket automatically change. All right, and we'll be looking at some examples of that. Now, rule number 3 says, when simplifying expression containing brackets or consisting of brackets, first remove the brackets and then add like terms together. So this So the three rule that we have then, we have the first rule says that what is outside, you multiply what is inside, basically the distributive law. The second rule says that if what you have outside is negative, when you multiply out inside, whatever the signs inside going to change to their opposite. The third rule is saying now that if we are simplifying where we have brackets, we first remove the brackets, then we add or subtract like terms together. All right? Is that clear to everyone? All right, so the fourth rule is really the distributive law. So the distributive law states that if A, B, and C are real numbers, then A bracket B plus C is equal to AB plus AC. All right, so based on the law, the distributive law, whatever you have outside, you multiply it, because remember, between the A and the bracket would be an invisible multiplication sign. So the operation here is multiplying. So if we are multiplying what is outside by what is inside are being added. So multiplying what is outside by what is inside, the multiplication going to be distributive. So you take A times a B, then you take the A again and times the C. So when we take the A times B, we get AB. We maintain what sign we have in the brackets. Then we take the A now times the C. So we get AC. And so that's how this rule works. All right. Any question about the distributive law so far? Let me see your hand.
Sir, I just wanted to go back to rule 1 for me, please.
All right. So let me go back to Rule 1, when removing brackets, each term within the brackets is multiplied by the quantity outside the brackets, which is the distributive law. Is that clear? Does that satisfy your curiosity? Those questions?
Yes, sir.
Okay, all right. So, what we...
Sir,
Yes.
can you show me an example of rule number 3?
All right, so we're going to be going through all of these now in terms of examples. So we'll have a set of examples for rule 1, then a set for rule 2, then a set for rule 3. All right, so that's what we're going to be doing now. So here, when we're looking at rule 1, we are using what is outside to multiply what is inside. But we are doing so in a distributive way. So to distribute means to give out. So as we're multiplying, we are kind of giving the 3 to each of what we have in the bracket. So that is the distributive part. So you take the 3 times a x, you're distributing a 3 to a x. Then we take the 3, then give me a second, guys. So when we take the 3 times the x, we are multiplying it, distributing it to the x, so we will get 3x. Then now we put back the sign that we have. Then now we take a 3, so that's the first one. Now then we take a 3, then we multiply it with the y. So we are distributing a 3 again with the y, so now we get the 3y. So the answer is simply 3x plus 3y. Likewise, down here, distributing 5, we're distributing 5 times 2x. 5 2's give you 10x. Keep the sign in the middle. Then we're distributing 5 times 3y. 5 is 15y. And so we get this answer here. All right. Now, we have to pay attention to the signs when we have them. So we have 4 times a, will just give you 4a. And now 4 times negative 2b. Don't overlook the sign. So this is going to be positive times negative. It'll give you back negative. So 4 twos 8. And then now we put back the b. Or if you want to treat it as how we have been doing it, you say 4a, keep the sign that is in the middle here. And then now 4 2 8, 4 twos 8. 4 times 2b give you 8b. All right, is that clear? Let me see the hands if you're following so far and you're okay with what I've just done. All right, good. Moving along. Now here we have a few more. So let's just look at these quickly. So here now we have m times a. Now we could easily just say m times a equal to ma. And then we keep the plus sign. And then m times b equal to mb. And so we'd have ma plus mb. Now, in the conventional sense, convention in maths means what we practice. So what we would practice in terms of our answer in the maths is that our algebraic term will be written in alphabetical order. So instead of saying ma, we would normally say am, right? So we would have am plus bm. That's how we normally will write our results based on what we practice. We practice to write these letters in alphabetical order. And what we practice, we call it a convention. Is that clear, guys? All right, so here for question 5, we have 3x. Don't forget the variables, right? So 3x, you treat all of that as one thing multiplying by the 2p. So you multiply the numbers together, 3, 2, 6, and then we multiply the variables together, x times p, so you will get what? 3, 2, 6, then you have px, keeping them in alphabetical order. And then now we have 3, 3 is 9, and then now the x times q, we will get, keeping it in alphabetical order, we will have 3, 3 is 9. Well, I have 9xq here, but it should be 9qx if we're keeping them in alphabetical order. All right. All right, for this one, 4a times 2a, multiply the numbers together, 4 2 is 8, multiply the letters together, a times a give you a squared, keep the sign in the middle here. Then now we do distributive again, 4 times b. Now that would just give you 4b, but don't forget about the a. So it becomes 4 times a, b. Any question about that, guys? Let me see your hands if you're still okay with this. Is everybody okay with this? All right, good. Moving along. All right, here we have now for rule 2, when we talk about negative signs outside the bracket. So negative 3 times positive 2, multiply this, we get negative 6, keep the x, so it's negative 6x. Now negative 3 times negative 5y, negative times negative give you positive. So 3 times 5, 15, and we keep the y, so this becomes positive 15y. All right, hope we're all following. So here again, when we have just a negative in front of the bracket, guys, that negative really means -1. So even though you don't have an obvious one here, you treat this negative sign as -1. So -1 times m give you -m. Then you have -1 times positive n. Negative times positive give you a negative. So that also gives you a -n. Now, likewise here, -1 times p give you a -p. Now, negative times negative give you positive. So this is positive q. I think I just said negative times negative up here, but this is supposed to be negative times positive, give you a negative. So if I said something a little bit out of place, just trying to make the correction. So here, -1 times m, -m, -1 times positive n will give you a -n. Here, -1 times p will give you -p. -1 times -q will give you positive q. All right, -2 times p. So remember, we are still doing the distributive property. And so we are distributing what we have outside with what we have inside. All right, so -2 times p will give you a -2p. And -2 times -3q, negative times negative, give you a positive. So that will give you a positive 6q. All right. Everybody is okay with that? Let me see your hand. Let me see your hands if you're okay with that, students. All right. I know that the rules seem pretty straightforward, but you have to be very careful because it is easy to make create errors when we're doing these. All right, people make errors with the sign quite often. All right, so we are looking at rule 3 now. If you have brackets before you can simplify, and remember, simplify just means making simpler. So in order to make things simpler, we are really, our aim is to add like terms, and wherever we don't have like terms, we write them in the form of expressions, right? So before we can add though, if they're in brackets, we have to remove them from the brackets. And we remove them from the bracket based on rule 1 and rule 2. So we're going to apply rule 1 and rule 2 here. Now for the first bracket here, what you notice is that there's no number outside the bracket, no obvious number outside the bracket. But when there's no obvious number outside the bracket, imagine that you have